Hi everyone! This video is going to deal with subatomic particles, their mass, their charge, and their location. And this is really the heart of reagents chemistry, because once we start understanding the inner workings of these subatomic particles, we can start understanding the elements themselves, which means we can understand how they behave, why they act the way they do, and this is the foundation for all of that knowledge. So we now know of three subatomic particles that exist: the proton, the neutron, and the electron. These subatomic particles each serve their own purpose in the atom. The proton is the positively charged subatomic particle that was the reason for the deflection of the alpha particles in Rutherford's gold foil experiment. The neutron is the neutral particle that exists alongside the proton that helps to make the nucleus such a small, dense sphere that was able to deflect those alpha particles from Rutherford's experiment. And the electron is the negatively charged subatomic particle that J.J. Thomson discovered when he did his experiments with the cathode ray tubes. So what we know about these three particles is that they all have distinct charges. The proton and the electron have a charge that's equal in magnitude but opposite in sign, which is to say, for every proton, if you have one electron to counter it, you're going to come out overall neutral. So each proton brings a +1 charge, each electron brings a -1 charge, and each neutron just kind of carries some mass along with it, but no charge. Speaking of mass, what we know about protons and neutrons is that they compose the majority of the mass of the atom. Remember, the nucleus is this incredibly dense center that's most of the mass of the atom itself. And because we can't talk about atoms, really individual atoms at least, using the unit of grams, the unit that we use when we discuss mass of subatomic particles is AMU, or atomic mass unit. This was a unit that was kind of defined to help us discuss such small masses. And the AMU, whether it's worth discussing or not, is defined as 1/12 the mass of a carbon atom that has an overall mass of 12. So this tells us the element, and this tells us the mass. So we've defined the atomic mass unit to be 1/12 of the mass of an atom with a mass of 12. Does it really tell us a lot about atomic structure? No, but it's something that's at least worth having in your back pocket if you need to talk about what an AMU really is. So both the proton and the neutron contribute 1 to the overall mass of our atom. The electron, on the other hand, is so tiny that it really has no bearing on mass whatsoever. Yes, it does actually have a tiny bit of mass, over 8,000 times smaller than a proton. But big picture considered, when we're looking at the mass of the atom, it contributes absolutely nothing. And again, what we know from Thomson's experiments and Rutherford's experiments is that the proton and the neutron are both located in the nucleus of the atom. They're what make up that small, dense, positively charged center. The electron, on the other hand, has to be floating around outside of the nucleus. And we'll pinpoint that location down a little bit more specifically later on.